Okay. Right. Hello, everyone. Phase one, get it to change slide. Sorry. Right, OK, good. So I'm Andy. I'm a principal engineer at News UK. News UK is a business which has a lot of brands that sit under it, so you might not have heard of News UK itself, but The Times, The Sunday Times, The Sun, Virgin Radio, Wireless Group, there's a whole bunch of different brands that sit underneath News UK. I've personally been working with The Times and The Sunday Times for around 8 months. I'm a self-described polyglot developer. I'm much more interested in solving problems rather than exactly which languages or technologies we're using. That's kind of where I sit on things, quite a pragmatist. I'm also a serverless enthusiast, like things where we don't have to manage stuff anymore. Let AWS do that where possible. If you want to catch up with me, my website's on there, and that's my Twitter handle. Actually, do you want to?
Yeah. Hi, everyone. So Kouros Aliabadi, of course, one of the consultants at ECS Digital. So I've been working with Andy for the last 8 months and with News UK on and off for the last few years. Really interested in open source tooling, quality, and particularly developer efficiency. And that's something that me and Andy have kind of found in common, where we like solving problems, not necessarily doing all the details, but finding cheap solutions where people can manage it for us, like AWS, of course.
Great. OK, so what's this all about, then? So what we're going to talk about today is a little bit about what we've been up to recently on Times Newspapers Limited and what we're trying to achieve. A few things about the technologies we've chosen to help solve our problems, a little bit about Fargate, not surprisingly, then some implementation details about how we've achieved it, and then how that's helped us and where we think we're going to go next, what kind of improvements we've got for the future. So in a recent history of the Times and the Sunday Times, we've been going through for the last around 2 years now a big project to modernize and re-platform our whole stack. So this was really born out of the idea that what you can see here is a whole different set of products that we've got. So like the iPhone, the iPad, Android phone, Android tablet, website, they're all actually different code bases and completely separate applications. And then behind those, we have specialized APIs. So one for web, one for mobile, one for tablet. And that's just for the content, and then there's everything else that goes on behind it. So you can see we have this really sort of broad set of a whole load of things that were going on. We're also sort of not necessarily on the most modern set of standards when it came to cloud. So we wanted to go about simplifying all this and kind of consolidating where we could so that we can move more quickly and get things out to our readers. Also optimizing for around our subscriber and guest experiences. So some of the stuff that's been coming out of that is our top one there is Times Public API. So that actually sits at api.times.co.uk/GraphQL. It's a GraphQL API that is running using Lambda. We're using serverless framework under the hood, API gateway, CloudFront, all that good stuff. That basically, the concept of that is to bring all of those disparate APIs, content and everything else under one hood, where we can have a single place for everything to come from. We also have Times components, which are a React Native-based set of components where we can build out the view layer. This provides the view layer for our hybrid mobile applications as well as web as well, using React Native Web. So that kind of consolidates everything in terms of the view and how that looks and how it's all presented to our users. We've been doing MVT. So this is talking around like A/B testing, that kind of thing, which is doing lots of experiments around optimizing user flows. More recently, particularly around our subscriber journeys, trying out different marketing packs, using machine learning algorithms to estimate propensity and all this kind of thing. And that's been using an in-house tool called MVT.js, which is at the moment client-side only. We'll come on to that a bit more later. And then open source tools. So things like iSpy, which is a high-performance visual regression testing tool. That is a little bit similar to like Backstop.js or Wraith or something like that, but we were struggling with getting that to perform how we wanted. So this is where that was born. Decider, which is a cider block calculator, which Kouros will cover a little bit more later, and loads more. So at News UK, we're trying to be open source as much as possible. Certainly for new projects, that's where we start, and we're kind of rolling out some of the older ones. So there's a whole bunch of links on the right-hand side there. If you want to use our components, they're open source. Like, go to the components.thetimes.co.uk. You can see everything that we've got there. That gets updated all the time. So what we're actually going to be talking about today as part of that broader picture is the website application, which is called Render, as in we are rendering HTML. This is what it looks like. And also, just to make mention as well, because it's kind of important, is the Times is a subscription product. If you didn't know, we're behind a paywall. So we kind of have these 3 different states for users. That's sort of guest access, so that's like anonymous users. That's where you get teased content only, so you just get a little bit of an article. Registered access, which I think at the moment is 2 free articles per week. These things get moved around a lot, but I think that's where it sits. So in exchange for a little bit of your data, i.e. an email address, then you actually get to log in and you get to see some content. And then we've got our full-blown subscribers. So that's full access to all our content. And I think that runs at £26 a month for digital at the moment. But there are sales all the time, so yeah, keep your eyes peeled if you're interested. So the problems we were trying to solve, we have, or had, inconsistent environments. So for Render, the EC2 instances were not brilliantly well managed, so dependencies and things like that that were ending up on the boxes were not necessarily consistent with each other, so our test environments might be different to our production environments when we're having drift. We also had, in that old stack infrastructure, provisioning was really complex, and that didn't help either, because that meant, if people don't really understand what something is, then they tend to shy away from it, and then we end up with all these sort of nasty problems again, where we end up with inconsistent states between different stacks. We also were suffering from environment bottlenecks. This is where loads of developers that we've got are all trying to deploy to a relatively small number of environments. So everyone's kind of fighting for environment time. That causes a really slow feedback cycle, as you need to find a slot, wait for a deployment, and then you can actually go and find out what's going on, and then you're like, oh, OK, now I understand, I've got a problem, and then you have to go back through the whole loop again. Also, for the same reason, it's kind of difficult to demo new work, particularly if you've got 2 or 3 different small teams that have all been working on the same product, and then you want to just sort of do demos one after another. You don't really have time to wait for deployment cycles in between and things like that. We also had pretty long pipelines, so it's like dev, test, UAT, staging, production, all that kind of normal stuff. But it takes quite a long time to cycle everything through that, particularly with all the other bottlenecks and things that are going on, to get a piece of functionality all the way through to production. And also, I guess in a more traditional sense, we had all or nothing releases. So once we were satisfied that something was working, we didn't have any real way of rolling this out in a sensible way. We'd just have to put the code out there. If we then spotted problems, we'd roll it back. But we've essentially exposed all of our readers to that issue in the meantime, which is not brilliant. So the technologies we've chosen to help us solve this problem, Docker. So that's taking our website render application, which was a straight to EC2 deployment, and containerized it. AWS Fargate, which is where we get those containers running in the cloud. Terraform to orchestrate all our infrastructure as code. Sorry, AWS, not CloudFormation. This is purely because we have so much more stuff than just AWS. This is kind of a common thing that we do across everything, and this gives us the flexibility to do it. And finally, Kouros, which makes all of our kind of performance testing and things like that on top of BlazeMeter or whatever a lot easier to script up. So now I'll pass over to Kouros, who can give us a few more details.
Yeah, sure thing. So first thing I guess we should talk about is Fargate, what it is, how it fits into the AWS ecosystem. So you can't talk about Fargate without talking about the Elastic Container Service. Elastic Container Service is a highly scalable container orchestration solution. So I like to think about it as similar to Kubernetes, but Amazon-specific and kind of a bit less faff, in my opinion. So Fargate, on top of this, is one of the launch configuration options for ECS. And the idea of it is that it makes it a lot easier to run. Rather than having the EC2 launch configuration where you have to have server provisioning, it removes all of that. So it removes server provisioning. There's no need for cluster management, no orchestration required either. So it's basically making it really, really easy. So one of the early complaints about Fargate was that it was kind of expensive. So that balance between the increased cost of running this managed service versus the time that you save on building and maintaining the solution. So that was kind of a bit of a debate when it first came out. But in January, they made quite substantial cost reductions. So in my opinion, I think it's a much more appealing option, Fargate, now, because I think in some cases in EU West, it was even reduced by up to 50% around that mark. So quite substantial cost reductions, making it really an appealing option when you think about the time that you go into maintaining these things. So it's allowed us to focus our energy on the things that we really cared about, which are, like Andy kind of talked through, improving consistency and the speed of feedback, getting things from developers' laptops to readers as quickly as possible. One of the other cool benefits around Fargate was that performance optimization was made really, really easy. So where you have much more limited options in all the permutations of things that can go on, the combination of continuous performance testing with Kouros, along with these simplified scaling and computer memory allocation, made the performance optimization of the infrastructure a lot simpler. Right, so I think we'll jump into a bit of detail. It's a slightly simplified architecture diagram. So I think first thing to look at here, we've got 3 VPCs, obviously. So we have VPCs for our old stack, which was all EC2 that Andy talked about a bit. We then have a VPC for our new GraphQL API. And then the main VPC that we're talking about today, which is the render VPC, so labeled new front-end VPC. So within this, we have our Elastic Container Service cluster sitting across 3 availability zones. So 3 availability zones because we're in EU West. And it sits across the private subnets. So within the private subnets, we run our cluster across all of them, and then tasks within the cluster are executed. So tasks is the Amazon term for basically your running container. So this is your running Docker container. It's running within the cluster, and it takes information from the task definition. So the task definition you see up here on the left, basically, it's just the configuration of where your Docker image is stored. So in our case, it's the Elastic Container Registry, some information about things like what ports do you want to expose, also some information about the configuration, the Fargate configuration that you would like. So within your task definition, you specify the CPU and memory allocation that you would like for each individual task. So this is the point at which you can really easily make your optimizations. So do you want to have fewer tasks running with much higher CPU and memory allocation, or would you rather have really small ones that you can scale really granularly and you can start to get really fancy and make sure that you're really optimizing the memory and CPU that you're using? Right, so to kind of see how this all ties together, so if we think about how traffic would come in through this diagram, so obviously there's a lot of stuff on here that is in the actual architecture, so it kind of comes in through Internet Gateway, through the load balancer to the cluster. The cluster manages it by sending the request to the task. The task does what it needs to do, which is our running application code, and then gets sent back out through the public subnet, through the NAT gateway, back out to the internet. So that's kind of how it all ties together in this diagram. OK. So a few of the implementation details around getting this set up. So one of the main objectives that Andy talked about for this piece of work was improving the speed and feedback in our CI process. So we had quite complicated pipelines previously, where there was lots of sequential tests and validations that would have to happen. It would go through more and more integrated environments as we went down. And we kind of saw this originally as a really good practice and the best way to go about doing this. But we found over time the maintenance of it and the speed of feedback was not quite where we wanted it to be. So we're trying to move towards a model where we push all of our testing and validation towards the pull request level. And that way, as soon as developers are making changes, they know everything's going to be OK. And once that pull request is merged into the master branch, we know that it's safe and it's passed all of our criteria. So in order to achieve this idea of all of our validation at a pull request level, we needed to have pull request environments. And that's one of the initial requirements around this piece of work. So pull request environments, effectively, you can spin up your UAT environment, your production environment, against your feature branches code. So you can have your application code with a full production stack for every single pull request. That means we can do all of the end-to-end testing that we need to do at pull request level. We can basically do all of the validation that we want to do really early on in the process, and it's been really cool. Along with things like demoing has become really easy. So all of a sudden, rather than having to use like weird grok stuff to show people your local version running on your laptop, you just have a production version of the application running that you can show people. So that's really great, and it really improves the confidence in stakeholders and the confidence in the team when we're making changes to the application. So there's some tricky details around getting pull request environments to work. So one of them is the strategy we've gone with VPC peering. So for each environment of the render application, we have a whole new VPC. So this means that we can, at one click of a button, without any pre-configuration, have the front-end environment completely created, which is really cool and was a complete necessity for us to achieve pull request environments. So one of the problems with creating this VPC peering model is finding non-conflicting IP ranges and CIDR blocks. So we created a small open source tool called Decider. I'm really proud of the name. I can't take credit for it, but I think it's really good. So basically, it's a small Node.js library that you guys can use open source. Go check it out. And it calculates CIDR ranges. So CIDR blocks, rather. So we've had similar things in the past in shell scripts and Python scripts, whatever. But we wanted to follow this open source first mentality. So we made it into an open source tool so that we knew that all the documentation was going to be up to scratch, all the testing of it was going to be up to scratch. And basically, we were forcing ourselves to make a solid product by putting it out into the wild. Right. One of the other things around VPC peering, the naming of resources in Amazon became a bit difficult because you need to have reproducible but unique names. So I ended up learning more about the naming constraints of Amazon resources than I ever really wanted to know, but it's something for a pub quiz one day, maybe. I don't know. And then the final thing is, so whenever I'm making changes to infrastructure or if we're migrating infrastructure, it feels like quite a scary thing. You're moving the platform underneath you, essentially. So whenever I feel a bit cautious about making changes, the first thing I want to do is write tests. So what tests can I put in place to make sure that I feel really confident about this? So we looked at Kouros as a continuous performance testing tool, and we analyzed, OK, what's our current usage like in production? What is the forecast readership, not only from subscribers, but also increased readership from our soft access, registered access? So we built in contingency to this performance profiling test. Every time we would make a change to our Terraform, to our infrastructure, we'd merge it, it would redeploy the infrastructure, and straight away, we would have feedback about how it's performing in comparison to our old infrastructure, and how is it going to support us for, with this performance test based on, the kind of load we can expect to see, not even just now, but also in 3 years' time as our readership increases. OK, so that kind of enabled us to do a bit of a TDD on the infrastructure, which was really, really cool. OK, so possible improvements for the future. So before I talk about the improvements, this diagram on the left, the idea here is just to describe how we can route traffic to different versions of the application. So with this VPC peering model, where we have one version of the application in this isolated bubble, and then we can have a different version of the application in an isolated bubble, one of the cool things we're able to do is, at DNS level, we can send traffic one way or the other to different server-side versions of the code. So like we talked about earlier, multivariate testing is really important at the moment for us, and we want to experiment with different ideas. What this allows us to do is, on a feature branch, you could create an experiment, deploy that experiment to production, and then just update some simple routing logic so that a percentage of your traffic, maybe based on one of their characteristics, gets filtered to a new stack of the application that has that experiment running. So this enables us to move away from the kind of client-side solutions that I'm sure you've all seen on different websites where you go to the website and it either is blank for a few seconds and then you get your version of the website, or it loads and it flickers and loads a different version of the website. It's not the best thing, and we really didn't want to have to force that experience upon our readers. So this will allow us to have a server-side solution where we can have many, many experiments running in parallel, and just depending upon the traffic flow and the rules that we put in place, we can pass them to one version or the other. So interestingly, pull request environments, this model's helped with. Server-side MVT testing as well, this model's helped with. And the final thing that it's enabled us to, well, the final thing that we want to do is risk mitigation. So automated deployment strategies like we talked about earlier. So be that blue-green deployments, canary. We haven't really decided which way we want to go yet, but I'm sure you can all imagine how it's going to be very simple with this model, because we just deploy a brand new version of our, say, green, and then all we have to do is change, say, the traffic flow rule in Route 53, so that now more traffic moves to version 2 rather than version 1 of the application. We can do this in parallel with our MVT testing as well, and it's a really kind of scalable solution, which is really cool. This idea of risk mitigation really fits into our quality strategy that we're putting in place. So the first stage of it was, like I talked about, moving all of that testing and validation from a complicated pipeline closer to the developers, closer to the pull request. Our second phase is really risk mitigation and monitoring. So when we make a deployment, we want to minimize the number of people we're going to affect with a deployment of new application code, as well as then have a better understanding of how it's impacting those people. OK, so that was all the presentation. I know that's a lot of information, but if you have any questions.
Got a question here. In terms of your configuration management, how does it fit within all these you showed us today? How complex was it, and how complex is it today to manage?
So configuration management before was, I don't know, there's all sorts of stuff going on. There's Chef stuff. I think there's Ansible somewhere as well. There's loads of things. And well, one of the reasons that we wanted to make a change was it was really complicated, and when you wanted to make a change, it was difficult to figure out if you were going to break things ahead of time. The move to Docker specifically has simplified that a lot. Our configuration now is it's a multi-stage build, but it's maybe 20 lines total. So yeah, it's made things much, much simpler for us, which is really, really handy.
Thank you.
After each deployment, how do you update the task?
So we update the task definition basically we manage it with tags. So we have like a latest tag or a relevant tag to.
If you have a latest tag, say for example, I'm working on one of the project now. So I have latest tag. Every time I deploy, it stays latest.
So you can also reapply your Terraform. That's what we do sometimes too, and it will just re-update the task. And,
OK,
yeah.
Thank you.
Hi, VPC Peering. You're obviously a fan of creating separate VPCs. And with regards to your front-end, back-end VPCs, what were the main reasons why you wanted to have them segregated in different VPCs? And also, second part of the question is, any issues you encountered with peering?
Sure. Well, maybe if I'll take the first bit.
Sure.
Yeah. So it doesn't come across here like quite how complex our stack is, but with the replatforming project, because we're moving so many things from like our legacy stack, which is extremely complicated, to a newer stack, which is more simple, but there's still quite a lot to it. It kind of makes sense to leave our applications, or at least we think it makes sense to leave our applications in smaller VPCs where they sort of have minimum access to each other, and then we can control those boundaries much more easily. And it stops us from having this sort of potential spaghetti connection mess. So as we are transferring things over, it's much more simple to understand what's talking to what. And if we ever need to pull out one of those pieces of the puzzle later and replace it with something new, that whole section gets a bit easier. So that's kind of the idea of grouping things up into sort of smaller VPCs. And then,
Yeah, so problems with the peering. It's surprisingly seamless, I would say. As long as you've got your side blocks sorted, it's fine. There is also like a configurable by Amazon cap on the number of peering connections that you can have within an account, but it's in the hundreds, and we've never even come close to it. As long as you keep on top of the number of environments that you're creating with some kind of monitoring, and you're tearing them down sensibly, like you're never going to get, unless you're, you've got thousands of engineers working on this one code base, you're never going to hit the limits. And outside of that, I mean, the naming was slightly fiddly, but we got there in the end.
it is a good point, though. The fact that we had this idea that you can just spin up loads and loads of PR environments, that then comes with the challenge of how do you actually make sure you take them down again afterwards so you don't have like costs on rolling and all those kind of things. So there is some like monitoring and overhead that you have to apply there just to sort of have good governance around your account and make sure you're not just like throwing money down the drain.
Thanks.
Hi. Did you consider using Kubernetes at any point? And what were the main trade-offs that you saw?
Okay, cool. So we actually do use Kubernetes as well. Like, actually, there's quite a lot in news which is moving on to Kubernetes. I think when we started this project, the Kubernetes stack wasn't ready, basically. So we wanted to kind of have those kind of capabilities, but we didn't have the kind of the time or the effort that we wanted to spend to actually set all that stuff up. That's really where Fargate was just such a godsend, really, because it is so simple by comparison. I think once you've got like your Kubernetes stuff set up and you're willing to manage it and everything else, then yeah, it's quite a good solution. But it is not a simple thing to get going with. So time pressure, and now with the cost differences as well, it actually looks even more favorable, in my opinion at least, to use Fargate. But that's obviously going to be on a case-by-case basis what ends up better.
Yeah, there's been a lot of debate around it.
Yeah.
Hi. I really like the idea of pull request environments. What were some of the challenges that you faced, and isn't that very expensive, basically depending on what you deploy in there?
Yeah, so pull request environments is definitely an interesting one. We knew that there was going to be some additional complexity that came around it, but we felt, looking at all the benefits we could get from it, we wanted to give it a go. I think the problems really come from this idea of having many to one, so many applications of your front end to one version of the API. That's where things start to get a bit complicated. If you have a one-to-one relationship, then it's kind of easy. But as far as managing it, like we talked about earlier, monitoring of the environments is really important, something we probably could improve on even. But yeah, managing the cost is okay, I think.
Yeah, I think from the cost perspective as well, like almost always the most expensive thing you have are your engineers. And if you're wasting their time, you're just throwing money down the drain. So the idea that we were getting bottlenecked around environments, that's a massive problem. We're just wasting money left, right, and center there. Even though it's not obvious because it's not on your AWS bill. The other part of cost as well is that you could solve this problem rather than having this many-to-one thing where you've got like lots and lots of versions of render which is all talking to the same API. The traditional way to solve this is just to spin up more production-like stacks. And if you're running those 24/7, that's incredibly expensive as well. So the idea that we could have these things which are much more ephemeral, that actually is quite a benefit. As long as you don't have like 1,000 PRs open, and so you have to get a little bit more constrained about what you're doing and just say, okay, leave a PR open whilst you need it, spin up, spin down the environments if you need to, that kind of thing. But that's kind of the way you manage your cost.
Yeah, and just one additional thing to that as well. The way that we ended up configuring like our task size, they were quite small tasks. So sometimes if you have a pull request, like you end up with a minimal number of tasks sitting there. And the cost of that is pretty low, really.
One question about the data behind it. Even if you're running multiple versions of the same application, they will still ended up in the same source database. Did you face yet the trouble around data scheme migrations and everything around that?
Do you want me to say it on?
Yeah.
Yeah, OK. So Render itself doesn't have any access to any databases. This is a very deliberate decision. It talks to well, a combination of APIs at the moment, but eventually we'll be talking to one GraphQL API. One of the really nice advantages of using GraphQL is that you can have this sort of rolling schemaless improvement, which means that if you need some new fields, you can add them in, but it's not going to break old clients. You kind of never have breaking changes in theory. So you can actually go an awful long way with that. Obviously, if when we come round to looking at having canary deployments and things like that with the serverless GraphQL setup, then yes, there is a database underneath that. We do need to deal with that. But the way to manage that is basically you always have backward compatible changes in your database until you've finished on a version, and then you can do a second migration to tidy up afterwards. So you can manage it through rolling migrations on the database as well.
Question. How long it takes to validate a pull request in this way, and how many pull requests you have open in average in parallel at one moment time?
So we try not to have too many open at once,
Yeah.
because it's just that idea of, once someone's made the work, we want to focus on getting that completed rather than starting new stuff. So overall validation, I don't know, less than 20 minutes, I'd say.
Yeah, something like that. And the pull requests we probably have on average maybe like 4 or 5 open at any one time max. Like we keep them really small because there's no need to leave them open for a long time unless there's some major issues that we need to deal with. But then we can always close it off and reopen it later. So
I imagine we're going to have more now that there's the draft pull request from GitHub that they released the other day.
Yeah.
So we'll have more now because we'll have people wanting to have their own PR environment on the stack they're working on, the feature they're working on. So
yeah, and maybe we'll need to manage that somehow as well.
Yeah.
It's just a new feature to deal with. Yeah, sure.
Brilliant. Well, thank you so much. Round of applause to News UK.
Cheers. Thanks.